All right, guys, let's talk a little bit more about acids and bases. So some properties of acids that you need to know about is that they taste sour. So things like lemons taste sour to us because of the citric acid that's in them. Now, I don't advise you going around just tasting a bunch of things to see if it's acidic or basic. So just be aware that food that you normally eat, if it is sour, it's because of acids. Acids also change indicators. Indicators are substances that change colors depending on if they're in an acid or a base. Litmus paper, which is what this picture is showing you, is something that you probably played with in middle school or even elementary school, but it turns pink when it's in an acid. Phenolphthalein is a chemical indicator, and it remains clear when it's placed into an acid. Acids react with metals to form hydrogen gas. That is one of our single replacement reactions on page 6 of our reference tables. They react with bases to form salt and water. That's our neutralization reaction. Neutralization reactions form water, and then the other product is called a salt because it's an ionic compound. So just remember, the word salt doesn't mean it's sodium chloride, that it has to have sodium, that has to have chlorine. It just means that it's an ionic compound. Acids conduct electricity. They conduct electricity because they're electrolytes. Strong acids are strong electrolytes. So if there was a light bulb involved, it would be very bright. Weak acids are weak electrolytes, so that light bulb would just be dim. Strong acids, there are 6 of them that you would have to know: hydrochloric acid, hydrobromic acid, sulfuric acid, perchloric acid, hydroiodic acid, and nitric acid. Now, if you're taking DP next year, you will have to memorize those 6. I like to remember them using CB spin. So you have hydrochloric, hydrobromic, sulfuric, perchloric, hydroiodic, and nitric acids. Any other acid that you have is weak. So anything that starts with an H is an acid. If it's one of these 6, it's a strong acid, therefore a strong electrolyte. If it's not, then it's a weak acid and therefore a weak electrolyte. Now, acids also have a pH below 7, and we'll get into pH more in our next lesson. Properties of bases. So bases taste bitter, bitter bases. Something that is bitter that I know you can probably taste in your kitchen is black coffee. So if your parents drink coffee, or if you've ever tried coffee with nothing in it, no creamer, no sugar, and that's the bitter taste. So a lot of people don't like black coffee because they don't like the bitter taste. Therefore, they add the creamer and the sugar. Bases also change indicators' colors. So here we can see our litmus paper changes blue in a base. So bitter bases are blue, BBB. Phenolphthalein actually turns pink in a base. So phenolphthalein, if we're combining acids and bases together, we can make it change color depending on how much acid or base is in that solution. Bases feel slippery. So something you should be using an awful lot of right now is soap. And that soap is slippery because it contains bases. Bases react with acids to form salt and water. There's that neutralization reaction again. Bases also conduct electricity, and so we have strong bases and weak bases, strong electrolytes and weak electrolytes. Strong bases are any metallic hydroxide. So take any metal and take our polyatomic hydroxide and put them together, and you have a strong base. The only weak base that you have to know of is ammonia, which is NH3. So we have ammonium, NH4+, which is a polyatomic. That is not a base. Ammonia, NH3, that's the weak base. And then bases have a pH that is greater than 7. And again, we'll talk more about pH in our next lesson. A couple definitions of acids and bases, what makes something an acid versus a base. An Arrhenius acid is a compound that will form hydronium ions in water. So hydronium is H3O+. It's a water molecule with an extra hydrogen, and that's shown down here on the left. So there's our hydronium ion. So HCl gives its hydrogen to the water to form that hydronium ion. So that's an Arrhenius acid. An Arrhenius base forms hydroxide in water. So here we have our water. It gives away that hydrogen to form ammonium, and we have hydroxide. Now, this limits our definitions of acids and bases, so it's not the best definition. We're going to talk about a better one in just a second. But acids and bases ionize, and ionize just means that they break into cations and anions. They break into ions. And so strong acids and bases will always break apart. So here we have HCl, and it's going to break into its H plus and its Cl minus all of the time. So notice the arrow goes one direction. Where our weak base over here will only ionize partially. So the arrows are going back and forth. So really this reaction is flipping back and forth constantly over time. So strong acids and bases break apart all of the time, 100%, completely ionizes. Weak acids and bases only ionize partially. So sometimes you find them as their original self, and sometimes they're not. Now, a better definition of acid and base is Brønsted-Lowry acids and bases. A Brønsted acid is a proton donor. And when we talk about proton, we're talking about the H plus. So the H plus, remember, hydrogen is number 1 on the periodic table, so it has 1 proton. A neutral atom would have 1 electron. And since the molar mass of hydrogen is 1, there's usually no neutrons. So if you have 1 proton and 1 electron, and then you take away the electron to form the positive charge, you're just left with a proton. So when we say H plus, we're just talking about a single proton anyways. So that's why sometimes you'll hear it as a proton, sometimes you'll hear it as H plus. But an acid donates that hydrogen ion. So an acid is a proton donor, where a base is a proton acceptor. It's going to gain that H plus. So down here on the left, it's losing that H plus. It goes from having 2 hydrogens to having 1. So that's a acid. This is our acid donating the hydrogen. And then here we have a base that's accepting another hydrogen. So acids are proton donors, bases are proton acceptors. Now, how many hydrogens an acid can donate is determined by the number of hydrogens in front of the formula. Remember, that's the key of knowing that it's an acid, is that it starts with H. So sulfuric acid has 2 hydrogens here. So we would call that diprotic. Diprotic because it can donate 2 hydrogens. And remember, hydrogen is a proton, so that's where the protic part comes from. So monoprotic would mean 1 hydrogen can be donated. Polyprotic, many hydrogens can be donated. Here, sulfuric acid, again, is a diprotic substance. It can donate 2 hydrogens. This is acetic acid, and acetic acid is the same thing as vinegar. There's only 1 hydrogen in front. So even though it has this H3 here, that's a part of the acetate polyatomic. It's not, those 3 hydrogens will not be donated. Only this one in front will be donated. So this is monoprotic. So acetic acid is monoprotic because there's 1 hydrogen in front. Now, amphoteric substances are things that can gain or lose hydrogens. And the only amphoteric substance you have to know about is water. So water, H2O, can gain another hydrogen and form H3O plus, our hydronium ion, or it can lose a hydrogen and turn into hydroxide. So water is amphoteric. It can act like an acid or a base. So what you have to be able to do is take a reaction and label them acids and bases. But not only that is going to the product side and labeling what the products are. So acids lose hydrogens to form conjugate bases. So the acid loses the hydrogen, take away the H, and we're left with A. And that's a conjugate base. And it's called conjugate base because it can reaccept that hydrogen and reform that acid. Remember, the reactions go both directions here. So acids turn into conjugate bases that can accept back the hydrogen. Bases accept the hydrogen and form conjugate acid because they could redonate that hydrogen. So base to conjugate acid, acid to conjugate base. So that's called equilibrium. That's a double-sided arrow. It can go both directions. The stronger the acid base is, the more likely the products won't reform them. So we like strong acids and strong bases because they form weak conjugates, meaning the reverse reaction most likely won't occur. So let's get labeling. Since water is amphoteric, if you have water as a reactant, you want to ignore it and figure out the other thing first. So here we have HF. It starts with an H, so we know it's an acid. If it starts with an H, it's an acid. The H then is going to get donated because it's an acid, and acids donate protons or are proton donors. So if I take away the hydrogen, I'm left with F minus, and the acid turns into the conjugate base. Now we can go back to the water. It's reacting with an acid, so it has to be acting like the base. You can only have one acid and one base. And a base is a proton acceptor, so it's going from 2 hydrogens to now 3 hydrogens. And a base turns into a conjugate acid. We're going to try it again. We have water, so we ignore the water. We look at the other substance. It starts with an H, so it has to be the acid. Acids are proton donors, so if we get rid of the H, we're left with ClO4 minus. And acids turn into conjugate bases. Now we can go back and look at the water. Since it's reacting with an acid, it has to be a base. Bases accept the hydrogen, so we're going to go from H2 up to H3. And bases turn into conjugate acids. Let's try it again. We don't have water at all this time. So which of these starts with hydrogen? This one does. So this is our acid. It's only going to lose 1 hydrogen at a time. So instead of H2, it's now just HSO4 minus, and the acid turns into the conjugate base. That makes NH3, which is ammonia, our only weak base that we have to know, acting as the base. And so the base accepts the hydrogen and goes from H3 to H4, and our base turns into our conjugate acid. All right, one more time. Here we have water. Water is amphoteric, so we're going to look at the other substance. It does not start with H, so this is our base. Ammonia is a base. It will accept a hydrogen and go from H3 to H4, and the base turns into the conjugate acid. This time, water then has to be acting like an acid because it's with a base. So the acid loses the hydrogen, so it goes from having 2 hydrogens to only having 1 hydrogen, which is hydroxide. I know that the letters flip, but remember, water is made of hydrogen and hydroxide. So when you lose a hydrogen, you're left with hydroxide. And our acid turns into our conjugate base. Please reach out if you have questions.